Hey everybody, Network Wizkid here, and today we are going to continue where we left off with the previous video on firepower transparent mode firewalling. So this is part 2. In part 1 we went over how you actually configure transparent mode, and in this video we're going to actually cover how we can configure the interfaces in transparent mode. If you've not watched part 1, I do advise you to go back and watch part 1 on my YouTube channel. I will also put the link in the description. And if you've not subscribed already, please subscribe. And if you want to be kept up to date with these latest videos that I make on CCIE related content, then please do subscribe to the notifications. That way every time I publish a new video, you will be kept up to date via email. So we're following the same process as we did in the previous video. So what we're going to discuss today are main points with the interfaces when configuring interfaces in transparent mode. So today we're going to focus on configuring inline interfaces. So these are the main points that I've pointed out from my notes and my studies on the CCIE security topic. So we'll quickly run over these. One or two are from the last video and they're still relevant for a recap. So the first one being only a management IP address exists, although you can have an IP address assigned to the BVI. So what that means is your physical interface, where your management interfaces will have an IP address. However, the interfaces that are going to be part of an inline pair or bridge virtual interface, the physical interfaces of those will not have an IP address, but the bridge virtual interface can be assigned an IP address. So transparent can block traffic inline, so inline mode, so that's what we're going to focus on today. All the other modes, so passive, span, ER span, they cannot block traffic inline. Traffic generated from the FTD is done so via the BVI and not the physical interface, so that's what I've already kind of pointed out, and we'll take a look at that when we jump into the lab. If dynamic routing is used, it's best to trust or fast path the traffic, so don't inspect traffic, so DHCP traffic, dynamic routing traffic, all that traffic. If you know what it is, it's best to just trust that traffic so that you're not placing an extra overhead on your device. And we'll take a look at that as well in the lab. Access control rules are dictated by the BVI rather than the physical interfaces. So when you're specifying access control rules, if you want to specify the source as being the BVI rather than the actual physical interfaces, that's how we use the BVI within the access control list. Multiple BVIs need a router to communicate with one another. So by this, what I mean is that if you have more than one BVI, and you want to communicate between the two, you do need to go to a router or a routing device to communicate between the BVIs. And last of all, you can have a maximum of 250 bridge groups, and within those BVIs you can have a total of 64 interfaces. So pretty straightforward on how we configure the interfaces. So once you've configured transparent mode, as we did in the previous video, I've put step 1, which is verify the topology. Now, although operating in layer 2 and it acts as a bump in a wire, it's still relevant to check where you're actually deploying your transparent firewall to make sure that it slots in nicely. So I always say, look at the topology first, look at your network, your environment before you deploy these devices, and understand how deploying that device in the middle of something could potentially impact traffic or resources that you've not necessarily thought about. Number 2, connect to the FMC GUI. So you've got your FTD device, it's in transparent mode, and it's joined to the FMC. Again, that process was covered in the last video, so go back and take a look at that if you've not yet seen that. Number 3, we then need to create a BVI and add the interfaces to that BVI. So once you've created the bridge virtual interface, you select interfaces that go into that BVI, and then you can save that and deploy those changes. So we'll take a look at that in the lab as well. Before deploying, we need to enable physical interfaces, so we need to turn them on essentially. And then number 5, I've got create and verify the access control policies. So I've put that on within these steps so that we can take a look at the access control policies and see how traffic would be permitted from a source to a destination. And we'll take a look at the topology we'll be using in a moment. Number 6, we will deploy the configuration changes. So all the config changes we've made, creating the BVI, enabling the interfaces, and adding or changing any rules we might have, we would then save those and deploy that to the FTD for that to take effect. And last of all, we'll verify the changes on the FMC, and we can also verify the changes on the FTD device as well. So as part of this demonstration today, we're going to be using this topology that you see on the screen. We have 2 virtual PCs acting as separate, they're in separate subnets, so that we can test the traffic flow from one side to the other, traversing through the transparent firewall. And we'll take a look at how traffic is impacted via the access control policies that we create. We'll also have a quick look at the configuration on router 2 as well as router 3, just to see how those interfaces connect to the firewall, or through the firewall. So with that in mind, let's go on to take a look now at the routing configuration. So we'll start off with router 2, which is the left router. And if we just take a quick look at the interfaces here, we can see that we have Ethernet 03, 172.16.1.9, and this is assigned to, let's just transition back, you'll probably see the topology clearer. So Ethernet 03 is assigned to this part here on router 2, so that's connecting to gig 00 on the transparent firewall. And then management is irrelevant because we've already got that configured. And if we take a look at now router 3, again we can see that within the same subnet, Ethernet 01, 172.16.1.10, this connects to the right hand route, or router 3, to the transparent firewall. So again, flicking back to the topology, we can see here Ethernet 01 connects into the transparent firewall. So as it's a layer 2 device, this whole segment that you're looking at here in the middle is on the same subnet, so there's no need to create different subnets for either side of the links between the firewall. The management is different, that's got its own subnet, and that's communicating with the FMC. That's pretty much straightforward from a routing point of view. What we'll just do quickly is we'll switch to the CLI of the... So what we'll do now is we will switch to the Firepower Management Center, and we'll start with our configuration. So logging in now to the FMC. The first thing we need to do is we need to go to Devices, Device Management. And click on the device that you have as transparent. So for us, we're using the transparent firewall here. So we'll click on the pencil icon to edit. And then let's just quickly move all these out so you can see them properly. Just flip between the two. There we go. So we've got gig 00 and gig 01. So these two interfaces were connecting to the either side of the routers. So if we just switch back to the topology again, so we've got gig 00 on the left hand side of the firewall and gig 01 on the right hand side of the firewall. So they're the two interfaces that we need to add to the bridge virtual interface. So what we need to do is we need to click Add Interfaces, Bridge Group Interface, and as you can see here, if we want to, we can give it an IP address. It's not starred, so it's not mandatory that we do give the BVI an interface IP address. So as you can see, we've got stars against the things that need to be specified. So we'll go ahead and give this a bridge group of 1. We'll add these interfaces in, so gig 00 and gig 01. And for the purpose of this video, just so we can actually communicate with the firewall, we'll give this an IP address. So 172.1.11/29. And that's it. We'll press OK with that. And now what we'll do is we can see that these interfaces are still down, so gig 00 and gig 01. So we'll go into those. And what we need to do now is we'll enable them. And we'll also give them a name. So gig 00 we'll call the outside. And then likewise for gig 01 we'll also enable that, and we'll call that the inside. And then once we're done with that, we need to save the changes. So those changes are saved now. Before we deploy that, we can take a quick look at the access control policies. Let's just go into this policy, and we can see at the moment we have an access rule that is already configured to allow any, and all we're doing is we're logging the traffic so that we can see the entries on the firewall. So we'll leave that for now, and then what we'll do once we've pushed the policy is we'll take a look at how to configure a quick rule to block a certain flow. So once everything's all good to go, we'll just click deploy. We'll click the device, so for us it's going to be the transparent firewall, and then we'll go ahead and proceed with the deploy. So this will just take a few minutes. So with that policy, all those configuration changes now applied, we'll flick over now to the CLI of the two virtual PCs, and we'll see if we can ping either side. So what we'll do is we'll first configure these. So I'll give the VPC5 an IP address of 192.168.20.10, and it's a /24, and a gateway is already configured at 20.1. What we'll do is we'll just verify that with a quick ping to the gateway. So that's good. And what we'll do now is we'll configure VPC4 192.168.10.10, and it's a /24 again, and the gateway is 10.1. And again, we'll just ping the gateway for clarification. There we go, that's good. So we can see that we've got the connectivity between the subnet. We also should have routes between both routers configured, so anything from router 2 or from the 10.0 subnet destined to 20.0, it needs to go via router 3. So let's just do a SHA-IP route static. So we can see there the gateway is going to go via 1.10. And we'll just verify router 3 as well. So that should be in the reverse direction. Fat fingers there. Static, so I'll just... So again, likewise, that's going via 16.1.9, so that's routers 2. So what we'll do now is I'll just flick back to the firepower device, and let's go to, we know now that we've got a policy that allows any traffic to any destination on any port configured, and we're just logging that traffic. So what we'll do now, you can already see there we've got some OSPF multicast traffic here. So what we'll do is we'll just quickly ping from VPC4. So we're going to ping 192.168.20.10, which is BPC5, and we can see that that's coming through successfully. Okay, so what we'll do is we'll just, to get this up a little bit quicker, we'll actually specify traffic that's initiated from VPC4 on the transparent firewall. Scroll up a little bit too far down there. So anything from 192.168.10.10, let's search on that. We should be able to see that flow. The traffic was allowed, we've just seen that, and we should be able to see that traffic through the transparent firewall, which we can. So we can see there that we've got an action for allow, and we can see that it's ICMP traffic. And just so it's a little bit clearer for you there, if we just zoom in there, you can see that the ICMP traffic is permitted. So what we'll do now is, just as a quick test, we'll ping the firewall, because we give that an IP address. So it was 172.16.1.11. We can see that that's timing out there. So we can see there that the VPC cannot ping that transparent firewall, doesn't know about it. However, let's have a look and see if the router can. So if I just up arrow there on the IP address, we can actually see that the routers, let's try it on router 3 16.1.11. we can see that the routers can ping that. So that's good stuff. So what we'll do now is, let's say for instance we didn't want VPC4 to be able to ping VPC5, but we wanted VPC5 to be able to ping VPC4. Let's go back to the firewall itself and we'll block that traffic now. So we'll go to policies, access control, into the access control policy, and what we'll do is we'll add a rule, and we're going to add this above number 1 so that it comes before, because we want to block this traffic. This is just going to be called test transparent, and what we want to do in our case is we want to block, let's go with the network, so we want to block 192.168.10.0, so VPC4's network, from pinging VPC5's network. So let's add that to the destination, and then we'll leave the ports as any, so we'll just block anything from being able to communicate, and we'll enable login so that we can see that being logged if we do get any hits on that. So what this is essentially doing is with the transparent firewall, we're using the IP address source and destination to block from VPC4 to VPC5, but VPC5 should be still able to ping afterwards. So we'll save that, and we'll deploy that, and while that's deploying we'll just flick quickly back to the CLI just to make sure that both VPCs can ping one another still, just before that change gets put in place. So we'll deploy that. Now let's flick back to the CLI. So this is VPC4, which we're going to block, but for now it should still be able to ping, and there you go, you can see that it still pings. And then VPC5, we can see that it pings 10.10. So that traffic should still be permitted after the deployment has finished on the FMC. So while that's deploying, let's flick back to the connection events. So analysis, connections and events. And we should be able to monitor that block traffic then. So in a minute we can see that we've got all allows. That policy is still deploying. So that policy is now being deployed. So now let's attempt to ping from VPC4 again. So if I just flick to that, and as we saw last time it was successful, this time it should deny that. So we can see there we're getting timeout messages, which is great and what we expect, and we should be able to see that on the logs on the FMC shortly. Let's just make sure that we can still ping from VPC5 to VPC4, and as expected we can do. So what we did is there we created a simple rule based on IP. You can do it based on BVI, like I said, that blocks source to destination in transparent mode, and that's using the inline interface, or inline interface mode. So we'll flick back now to the connection events, and as we can see at the top, we can see that ICMP has been blocked to 20.10, which is a rule that we created. So that's what we expected, and that's what we wanted to happen. So just to finish off, we can flick to the CLI of the FTD device, and we can see what the config looks like on the CLI. So I'll just get that up now. Okay, so if I just do a show run, and then we can have a look at the output. So the points to take note of is we can see that interface gig 00 is assigned to bridge group 1. We can see the name that we created, so it's still like the ASA code, so name if outside. Likewise for interface gigabit 01, we can see the same, the only difference is the interface name that we created. We can then see further down interface BVI1, so it creates that interface for us, and in our case we did assign an IP address to that interface. And the rest is pretty much straightforward. The rule that we input is here, so we can see that we've got a deny from 10.0 subnet to 20.0, and that's just denying IP, so it's denying anything. And we can see that we've got login enabled for the start of that flow. So that is how you can configure transparent mode inline interfaces. If you have enjoyed that video, please feel free to subscribe. Again, hit that notifications button if you want to be kept up to date with all the other videos that I will be doing from this time forward. If you have any questions, feel free to drop them in the comments section or reach out to me on my social media platforms. The links are here. I will also include the links in my video description. But until next time, thank you for watching.